Good morning, Year 8. Welcome to our third video lesson together. Today we're going to be looking at Pythagoras' theorem and we're applying it to real life scenarios. So I'm going to begin the lesson by showing you an image that I recently saw on Twitter. Now, as soon as I saw this picture, I thought to myself, well, there's lots of nice maths that we could consider when we look at this photo. So I'm going to leave you with 3 prompts. I'm going to ask you, what has happened in this photo? Why has this happened? And can you think of any maths we could use to explain this? Alright, so pause the video if you need to. Okay, so what has happened? Well, clearly this path was designed to be walked on. Whoever designed this park obviously wanted the pedestrians to walk along this concrete path. However, this lady, she's a bit of a rebel. She's completely cut that corner. Right, and we can see that lots of people have had that same idea and have decided to walk on the grass because there's not much grass there anymore, is there? So, the first part of this lesson, we're going to be trying to use some maths to explain why this has actually happened. I've tried to recreate this image using my advanced Microsoft Paint skills. So this is our park, and here's that kind of grassy area. So, to get from point A to point B, obviously this path was designed to be followed in this direction. So if you see these arrows to get from A to B, the designer wanted you to go up and then left like so. But actually, just like that lady, most people have gone, nope, not doing that. They're cutting this corner completely. So they've taken a different path to what was intended. So remember what that prompt was. The question was, well, why have they decided to go from A to B? Why have they decided to cut that corner? Okay, why was that a better route? I'm going to give you a clue. I'm going to tell you that this length would be 5 meters and this length would be 5 meters. It's completely up to you how you do this. You can either just listen to me talk you through the whole example, or if you're feeling confident with the last couple of lessons, you might want to be able to apply Pythagoras' theorem now to this question and see if you can answer my question. So the question is, why have people chosen that route instead of the intended route? So for me to answer this problem, I'm going to use Pythagoras' theorem. Okay, I'm going to begin by labeling this right angle triangle. So look where I'm wiggling my cursor. So I'm tracing a right angle triangle here. Okay, and when I label my right angle triangle, I know that this, the longest diagonal length, that is always C. I know that because it's opposite the right angle. So remember, Pythagoras' theorem is a squared plus b squared equals c squared. The two smaller sides squared and added together equal the larger side squared. Now we're going to substitute in what we know. Instead of a squared, we're going to call it 5 squared. Instead of b squared, we're going to call it 5 squared. I don't know what c is yet, so I'm just going to leave it as c squared. So let's do some maths. We know that 5 squared is 25. So actually this question is 25 add 25 equals c squared. Also, we know that 25 plus 25 is just 50. So 50 equals c squared. So this number squared equals 50. So to get from c squared to c on its own, let's balance both sides and square root. So just like what we've done for the last couple of lessons. So c is the square root of 50. And using my calculator, that's going to give me around 7.07 meters when I round it to 2 decimal places. So all of this maths that I've just done, this tells me that that hypotenuse length, that corner that they've cut, is actually 7.07. So let's think about my original question. The question was, why have people decided to go across the mud instead of taking the path? Well, when we think about it, the intended route to get from A to B would have been 5 plus 5. So this initial intended route would have been 10 meters. But actually, if you cut that corner, it's a shorter distance. It's 7.07 meters. So one of the most common questions I get in my maths lessons is, oh, but sir, when are we ever going to use this in life? So Pythagoras' theorem, there's lots of really nice real life applications that you could use. Some of you might not use Pythagoras' theorem after you leave school, but lots of you will do in certain jobs. So for example, let's say you became an engineer, so that's someone who builds bridges like this. You could use Pythagoras' theorem to work out how long each of these beams, these supporting beams, would need to be. Similarly, in a structure like this, as you can see, to support this wooden structure, these beams are keeping the whole thing together. For you to figure out how long they need to be, you could use Pythagoras' theorem to work that out. So in today's lesson, it's going to be all to do with those types of problems. So it's applying Pythagoras' theorem to real life situations. On Google Classroom, on the post where you found this video, you'll find an attachment. I want you to download that, please. It's got lots of questions where you need to convert the sentences and sketches into Pythagoras' theorem and solve the problems. All right. As a tip, just look out for any right angle triangles, because right angle triangles is your clue to apply Pythagoras' theorem. And in some of those questions, there might not be any right angle triangles in the sketches yet. If you don't see a right angle triangle in the sketch, you might want to think about drawing some extra lines so you can see a right angle triangle, and that way you can use Pythagoras' theorem. Okay. If you are getting really stuck with this at all, I'm around all day to help you, so please just send me an email or message me on Google Classroom, please. All right. So if you pause the video now, and I'll reveal the answers in a few seconds later in this video. Okay, and then these are your solutions that you should have had for that task. Okay, thank you very much, guys.